Well, this is 9.7, and this is graphing systems of equations, well, systems with quadratic equations. So just to remind you, when we solved linear equations, when we first began, remember we were finding where the two lines intersected. Just a reminder of what systems are. So we want to find that intersecting point that worked in both of the linear equations at the same time. And we did use the graph and check method. We used substitution method. We did those types of things, but we can use both of these to solve a system of equations involving nonlinear equations. In other words, quadratics. I will tell you, and everything we're going to do in this section is going to be one linear and one quadratic, not two quadratics. So it's going to be one linear and one quadratic. So kind of picture that, just to keep your give you an idea. We're going to have like a quadratic function that looks like this. Okay, and it's going to be intersected by a line that might look like this. So just kind of keep that in mind, that most likely we're going to have two solution points, unless it just intersects right at the vertex. It possibly could not intersect at all. If it was a horizontal line, there might be no solution whatsoever. So just kind of keep that in mind. Most likely we're going to have two solutions. Okay, so we're going to do the first thing we're going to do is the substitution method. And that's the first thing we're going to learn right here, using the substitution method. Obviously, we can graph, but sometimes graphing is not the best way to do things. So I'm going to go ahead and put this up, and we're going to use the substitution method. And the first thing is you want to solve one equation for y. Well, our first equation, our linear equation, is already solved for y. So that makes it nice and easy. So in other words, we're going to substitute this right here, this 3x plus 2. Oh, I put an x there, making it look like that's an x. I'm just was marking that equation. I'm going to put this part of the linear equation, and I'm going to substitute it in for this y right here. So here we go. We're going to substitute that in. We're going to say 3x plus 2 equals 3x squared plus 6x plus 2. Because we want to find when both of these y's are equal. When are those y values the same? So if we know that when these y's are the same, these two items have to be equal as well. So we're going to subtract the 3x from both sides. And I'm going to line these up with my like terms. And I'm going to subtract 2 from both sides. I've noticed a lot of students have forgotten to do this part. Why will my minus not stay? So I'm going to subtract 2 from both sides. And that leaves me with what on this side, which is exactly what I need. So I'm going to have 0 equals. And then when I combine my like terms, I've got 3x squared. And then 6x minus 3x is positive 3x. And then what happens here? Guess what? Those 2's cancel out. So instead of using the quadratic formula, I'm going to factor. This one will be much, much easier to factor because I can just take out a 3 and an x, leaving me with, well, let's see, if I take a 3 out of there, that leaves me with 1. Take an x out, that leaves me with 1x. And then if I take a 3x out of that, that's 1. So it leaves me with 3x times x plus 1. So let me just double check. So 3x times x is 3x squared, and 3x times 1 is 3x. Okay, so I factored correctly. So now I know if 3x times the quantity x plus 1 equals 0, I know that one of these quantities has to be 0. So I know that 3x has to equal 0, or I know that x plus 1 has to equal 0. One of those two things has to be 0. So my solutions are x equals 0 and x equals negative 1. Now, let me be very, very clear. Okay? These are not solutions to the quadratic. Okay? These are not your x-intercepts. Okay? So they are not intercepts. What are we looking for? Keep in mind, we are looking for where this line and this parabola intersect. So this time what my solutions are x values of those 2 points, those 2 random points. They're just x values of those 2 points. They're the x coordinates of those 2 points. So right now, here's what I've got. My solutions are 0 something and -1 something. And that's all I have at this point. Okay, so now I want to take, when these x values are 0 and -1, I want to go back up here to this first equation, y equals 3x plus 2, because it's the easier of the 2 equations to solve for y. I could use the quadratic one, but y. Okay, and so I'm going to substitute 0 in for x, and I'm going to solve. Y equals 3 times 0 plus 2, which just ends up being, because 3 times 0 is 0, 0 plus 2 is 2. So when x is 0, y is 2. And then I'm going to do a -1 in right here. So I'm going to substitute that -1 in. And you guys, 3 times -1 is -3 plus 2, which equals -1. So when x is -1, y is also -1. Now, these are the only 2 points, values of x, that will satisfy both equations above. These are the only 2 points. Values of, I should say values of x and y. So those are my solutions. Okay, they are different than the x-intercepts. Remember, I'm looking for intersecting points. So as we go through this, please keep that in mind. Okay? Let's see if I can get this. All right, we're going to scroll on down. Maybe. All right, so you do the guided practice. Pause the video, try the guided practice, and then you can start the video again and you can double check. Okay? Okay, I've already started this problem. I want you to double check to see if yours is right. I took the 4x plus 4 and substituted it in for the y. Set these 2 things equal to each other, because if the 2 y's are equal, then these 2 have to be equal. I subtracted 4x and 4 from both sides, subtracted them both, because they're both positive over here, so they're negative over here. Combine my like terms. Now I'm going to look for factors of 2 that have a difference of 1. Well, that is 1 and 2. So I'm going to factor these into, okay, I'm going to factor these into x and x. I know that 2 and 1 are my factors of 2. I need my 1 to be negative, so I need the larger number to be negative. And again, we're going to FOIL to check. We could FOIL the plan. Sorry, I know, bad joke. Okay, so x times x is x squared, and then my outer gives me -2x, my inner is +1, and -2 plus 1 is -1x, so I'm good there. And then +1 times -2 is -2. So my solutions are, for my x coordinate, either x plus 1 has to be 0 or x minus 2 has to be 0. So my x coordinates of the intersecting points are -1 and +2. So I'm going to go ahead and write those up here. So -1 is one solution, and +2 is the x coordinate of the other solution. Now I need to solve for my y. So y equals 4 times -1 plus 4. So that gives me -4 plus 4, which is 0. So my y value here is 0. If I do the next one, y equals 4 times 2 plus 4, which is 8, plus 4, which equals 12. So when x is 2, y is 12. Now I should substitute those back in to check. 4 times 2, 12. I should substitute those back into here and check. I'm going to show you what that looks like. We know that it works in the first equation. So I'm going to do 2 and 12 up here. So I'm going to have y equals 12, and I'm going to do 2 squared plus 3 times 2 plus 2. So 4 plus 6 plus 2, and 12 equals 12. So I checked this point. I should probably check the other point just to be sure, but I can already tell in my head it's going to, because negative 1 squared is 1. 3 times negative 1 is negative 3, and 2 plus 1 is 3, and 3 minus 3 is 0, and 0 equals 0. So just check those in your head, okay? Now, going on down to the next problems. Down here, let's look at the back side of the page. I'm try to keep this short. Systems with one linear equation and one quadratic. That's what we already did. There's 3 possibilities. One we said was no solution. The line would never touch the parabola. The only line that's never going to touch a parabola, and this is a bad example, is going to be a horizontal line, where that is either below or above the parabola. Okay, so there's an example of no solution, only a horizontal line. Okay, one solution would be a line that only crosses at the vertex. Okay, and then 2 solutions that intersects the entire parabola. So solve the equation using a system of equations. Solve this equation by using a system and check your solutions. So in other words, we've got 2x squared plus 3x minus 1. We have this quadratic side equal to this linear side. So if we graphed this and we graphed this, we would have something that looked like a parabola with lines going through. So write a system by setting them both and take them both apart and going ahead and graphing them. So we're going to graph y equals x plus 3, and we're going to graph y equals 2x squared plus 3x minus 1. So graphing y equals x plus 3, here's my y-intercept. My slope is 1 over 1. So there is my line. Okay, I can't change colors on this, so I'm sorry. Here I'm going to do opposite of b over 2a, which is negative 3 over 2 times, negative 3/4, really? That's my axis of symmetry? I would so much rather just solve. So maybe I could factor it. I'm going to try to factor it and see where our x-intercepts are. Let's go ahead and factor. See if we can. 2 and 1 and 1 and 1. I don't think we're going to be able to factor because we need to have a difference of 3. And I'm going to have a sum of 3. Interesting. So we can't really factor to graph. See why graphing is never a good solution? I'd rather just solve it the other way and find my x values that way. So negative 3/4. Did I do that right? The opposite of b over 2a. So now let's put this back in. So let's do 2 times 3/4 squared. Negative 3/4 squared is 9/16. Yuck, that's ugly. Plus 3 times negative 3/4 minus 1. Okay. So this makes 8. So we end up with 9/8. Sorry to write 16. So 9/8. And then this would be negative 9/4. I'm going to change that to 8. So it's going to be negative 18/8. I'm going to change this to 8, and this is minus 8/8. Just changing everything to 8 because that's what I want to do. Okay. Finding my y value. Yeah, so this is my y value. Sorry. So 9/8. Let's see. Negative 9/8 minus 26/8. What's 26 minus 9? That'd be 17/8. Oh my gosh. All right. We are going to just forego this one because I don't really like it. Only the x values of each point are the solutions to the original equation. Oh, there's an interesting tidbit. We need to remember that. We might do this problem in class or do a different one that actually graphs more easily. I may be making errors because I'm in a hurry to get this done before my conference time is over. So if you guys see any mistakes that I've made, just point them out to me tomorrow. Anyway, I think that's all we're going to do right now for this video. The biggest thing I want you to know is just that we're not going to do a guided practice on the graphing. That's terrible. So we're going to just basically show that I think the other way to solve is much, much easier. All right, that's it. Have a good night. See you tomorrow.